Welcome to ETHDam, to ETHDam, to ETHDam, to ETHDam, to ETHDam.
Hello, hello, hello. Morning. I'm Laura from JobStash. I'm going to be sort of guiding us through this morning. We've got a few really good speakers throughout the morning. Just a few things. The talks are around 15 minutes. If we have time, we'll try and open it up to Q&A. If not, then the speakers usually stick around for a few minutes outside after, so feel free to go up to them and have a chat to them after. So please welcome to the stage Dennis to speak about enshrined tokens on Ethereum. So.
Hello, everybody. Good morning to this start of the day presentation on what we're working on. Let's get to it. Yeah, so I think, well, actually this slide's supposed to be somewhere else. Enshrined tokens, what does this mean? What does this mean in this context? Some of you might know, Neil has been working on a coming ZK rollup with sharding. We call it ZK Sharding for Ethereum. And that's something I want to dig in further today, and in particular around our token design. So this is like the meat of it, but let's save the best thing for last. We'll get to it later. Yeah, our agenda, I think it would be helpful to understand first about the scaling of rollups, the fundamental knowledge about sharded decentralized systems. These are the goals of what I'd like to touch upon today. From a high level, because I just have 15 minutes, I want to run through what sharding means in general, rollup sharding, and our token design, and then a little practical example of how we've done that with dApps, as much as I can squeeze into this time frame, actually. So yeah, what is sharding? Some of you might know it from traditional database systems. It enables us to scale throughput in databases by just splitting it by some granular level. So in the typical case, we split it by on the user level. So then we have two different sets of the database, and they handle different loads for the different user subset. Sometimes it's by geography, et cetera, but this enables us to just remain performant at a larger scale. So how does that look like for a network? Very similar, actually. Ethereum has an account model, so we do it on an account level. So every shard you can see as its own subnetwork, and that's actually what it is. It has its own validator set and its own consensus, and it communicates across shards with async comms. So that's something that's handled by the core program that allows you to send a message to some other shard, but that's executed at a later block. I think that's a little bit like, on a high level, how this looks like. Every shard has its own gas model and its own gas pricing mechanism. So it can very well be that the gas prices are just very different in one shard than the other, depending on usage. They always depend on usage. They all have the same gas mechanism. It's just like one will be more expensive than the other just based on usage. That's what I mean. So what problems do we want to solve? Well, exactly, scaling. We want to avoid there being just a single pool on Uniswap that dictates the price for the whole chain. We very much like to avoid that. So in fact, we want to give developers this flexibility to choose what components of their application they'd like to possibly have very high levels of activity without it influencing the rest of their app. So we want to contribute to the decentralization of rollups, application scaling, and of course utilization efficiency. These are all things that come together with sharding. But why sharding? Because by doing this, you're able to at will choose a level of scale that you need at the point in time. And that's actually how we're going to organize the protocol too. We're going to be able to say at will how many shards we want to add to the system based on the usage there is. So layer 2 sharding, yeah, I touched upon this before. we use, each shard is, you can see it as its own subnetwork. What is a little bit not, we touched it here a little bit with the ZK proof and validity proof data commitment. There are ZK proofs for every state transition in every shard. And that's in order to match higher security guarantees that Ethereum is able to offer because of its degree of decentralization, which we don't expect to have at the start stages of mainnet. We're on testnet right now, by the way. So, okay, great. So this brings me to ERC20. I can see I'm still on time here. So some of you might know it. I think it summarized is actually this image does it very well. It's a single program running on that holds the state for the balances for all accounts that hold the token. So this program will update who owns what whenever a transaction is sent to the Ethereum network. So if I send a Pepe coin to my friend Vlad, then Vlad is going to get the Pepe coin, but this contract will have to update the address with the Pepe coin I had to Vlad's address after the end of the transaction. So it all happens in this one place. That's the gist of ERC20. And that's exactly what happens. So that's what we see here. I think it all goes through the one contract. Everything is saved in this one particular space of storage. So why can't this work in sharding? It's because it will require an async call for calling this one contract in this one shard for wherever else you are on the network. Especially if you're like in a multi-sharded setup like I ran through before, you're gonna have to wait at least 2 blocks in advance until you know what happened or you know what the outcome is of your Pepe coin transaction. So it doesn't really. It kind of defeats the purpose of trying to scale the chain with sharding. If you have this degree of centralization in the end, you might as well not have done the sharding because, you'd want it to happen individually and in parallel in every shard. So what do we need? We need an ability to create new tokens, owner control and supply management. We actually need all the functionalities of it. Without having the need to call a single shard. So, luckily on NIL, accounts are all smart contracts. So, we can customize the logic for tokens by updating pieces of the account. And as the model stands today, we want to make sure that every account on NIL is able to transfer whatever token it has within the shard and update its own state by doing that. And if a transaction is involved in another state, there is a separate token manager that updates the state for that account. So I think I can go now back to my first slide here. Here. Yes. So this is the meat of it. We have, for transactions that happen within a shard, I think it's very easy to imagine. This is particularly for the cross-shard transaction. For transactions that happen within a shard, we just call the single token manager within that shard. But in a cross-shard transaction, the token manager is able to handle token updates for cross-shard transactions. So it's a very similar setup to what you would find in Interop in Ethereum. Difference being that the system handles token management across all shards. So this is abstracted away from the developer, particularly cross-shard token communications. So let's continue here. Great. Okay, so how does that work with DEXs and dApp scaling? We adapted Uniswap v2 to make use of every shard. So instead, like as I mentioned previously in my first example, is that we had Uniswap v2 with a single shard in which one pool affects the gas prices for the whole network, which is not the best. So with a multi-sharded design, we're able to deploy a pool for every shard. And then, that way, if there's one popular pool, it will not affect the other pools in other shards. So every shard had its own pool, and whenever a user wants to perform, say, a multi-shard swap, they will call multiple shards separately. So it's one application of how to do a DEX in multi-shard setups. Actually, that'll be it. So thank you.
Thank you, Dennis. So I think we've got time for a few questions. So does anyone from the audience have a question? Okay, perfect. I'll head to you, and then I'll head to you.
Hey, thanks for the talk. Could you please elaborate on eventual consistency for read operations? Let's say I have a smart contract that wants get balance of specific account for your like Pepe coin in your C20. How does it work? Thanks.
For read operations, it would be asking the token manager. That's how the design is being implemented as we speak. Actually, the token manager will handle read operations for your local shard for balances in some other shard. So balances for the token manager, actually for any cross-shard communication, as it stands right now, will be propagated among the other shards. Yeah.
Cool. I think we had another question over here. Perfect. Question time.
Thanks for the presentation, Dennis. My question, I saw on the slides up to 3 shards at some point, but I guess I'm wondering, is there a mechanism to dynamically adjust the number of shards?
Yeah, that's something we're working on right now, but for our mainnet release, we will start with a fixed number of shards.
Cool, cool. Are there any more questions or... Cool. I have a question as someone who did not know what enshrined tokens were until 15 minutes ago. If there was sort of any key takeaway that you'd have for anyone who just learned about this concept today, what would you want them to walk away with?
That on nil, you don't need to worry on there being a presence of your token in some other shard and you handling that yourself. Nil handles that for you. So your application is able, if you deploy a token today on Ethereum, you have to worry on its presence on different shards, or different rollups actually. On nil, that's all handled for you. So you just have to deploy it on nil, and then it's there for available in all shards.
Amazing. Cool. Thanks, Dennis. So great.